What do the average rates of change over the intervals -2, 0, 0, 3, and -2, 3 indicate about the given functions? So we're going to go through a couple different examples here that actually have numbers. So first of all, we have to recognize that what we're given above in the question, the -2, 0, those are both x values indicating an interval. So essentially they're saying find the slope from the x-coordinate of -2 to the x-coordinate of 0. So we need the corresponding y's, which we pull off the graph. So -2, 1, and 0, 1. Then we find the slope. So y2 minus y1 over x2 minus x1, which is 1 minus 1 over 0 minus -2, which is 0. Then we do the same thing for the interval of 0 to 3. So for the interval of 0 to 3, again, it's saying what is the average rate of change from the x value of 0 to the x value of 3. So we need both coordinates, so 0, 1, 2, 3, 1. Then we find the slope. So 1 minus 1 over 3 minus 0, which is 0 over 3, which is equal to 0. And lastly, what is the average rate of change from -2, 1 to 3, 1? And we find our slope, so 1 minus 1 over 3 minus -2, which again is 0 over 5, which is 0. So if we look, we actually have the same average rate of change over for each interval. So in conclusion, f of x is equal to 1 has the same rate of change, which is equal to 0 over every interval from, I'm going to say from A to B, meaning that any x values that we put in here, if we find the average rate of change, it's always going to be equal to 0. And the reason why I'm choosing two different variables is because we need two different x values. Let's try another equation. Our next equation is g of x is equal to 1/2 x minus 1. So as you can see, this has a slightly positive slope. We're going to start by doing the interval of -2 to 0. So we first need to find the coordinates from -2 to 0. So that means we have -2, -2 to 0, -1. Then we find our slope, which is y2 minus y1. Oops. -1 minus -2 over 0 minus -2. Then we simplify, and it becomes 1/2. We do the same thing for the next interval of 0 to 3, so we need the coordinates. That's 0 to 0, -1 to 3 and 1/2. y2 minus 1, or sorry, y2 minus y1, so that's 1/2 minus -1 over 3 minus 0. So if we take the negative, or the minus sign and the negative, that's going to become 1/2 plus 1 over 3. So 1.5 over 3, which is the same as 3 over 2 over 3, which simplifies to be 1/2. And the last interval is -2 to 3. So So we take our coordinates, -2, -2, 2, 3 1/2. Then we do y2 minus y1. So 1/2 minus -2 over 3 minus -2. And that actually simplifies to be 1/2 as well. So let's look at our average rates of change. We have 1/2 for each of them. So therefore, or my 3 dots here means therefore, we have a constant average rate of change, which is equal to 1/2 over the interval of A, B. So any 2 points that we pick on that line is going to have an average rate of change of 1/2. It's going to have a constant slope is essentially what we're saying. All right, last but not least, we're looking at a parabola now. So h of x is equal to x squared. We're looking at the interval of -2 to 0. So we first come up with our coordinates. We take them from the graph, -2, 4 to 0, 0. Then we find the slope. So just imagine that we were doing a straight line connecting those 2 points. That's what our average rate of change is. 0 minus 4 over 0 minus -2, which is equal to -2. Then we do the next interval, which is 0 to 3. Whoops. So our coordinates are 0, 0, 2, 3, 9. We find our slope, y2 minus y1 over x2 minus x1, which is 9 over 3, which is 3. Now notice already that we have 2 different average rates of change, but we have to complete the problem and do our last interval from -2 to 3. So we find our coordinates. That's -2, 4 to 3, 9. Then we find our slope. So 9 minus 4 over 3 minus -2, which is equal to 1. So we have 3 different average rates of change. So in conclusion, we do not have a constant average rate of change, therefore non-linear function. And that's it.